Hey guys, how's it going? Welcome to day 32. Today we're going to take a look at the extreme value theorem, aka the EVT. But before we talk about the extreme value theorem, I want to talk about absolute extrema, which would be either absolute maxes or absolute mins. Talk about an absolute min real quick. So an absolute maximum means that, on a specific interval, it's the highest point on the graph when f of x reaches its maximum value. Okay, so for example, let's say we have a graph that's goes from on the interval -5 to 5. Okay, so if that is our graph here, that's our function f of x. Okay. We see local max here. We also see another local max over here. But not only is that second local max a local max, it is also the absolute max. Because it's the highest the graph ever gets. Okay. Using the same graph as an example, right, we have, you could also maybe call 5 there, that endpoint maybe a local max, but it's not the absolute max. Let's take a look at absolute minimum, then would be the lowest f of x value on an interval. Now, if the interval is -infinity to infinity, and plus or minus, like the limit as x goes to plus or minus infinity, if the graph, like if you think of y equals x squared, if I say what's the absolute max of y equals x squared, that has no absolute max because it always keeps getting higher and higher and higher as x gets both bigger and smaller. Okay, so an absolute min then would be the lowest f of x value on an interval. If we use the same graph here, right, we see a couple of local mins here. And actually our lowest overall point is at that endpoint -5. And this graph right here kind of highlights the possibilities for where absolute maxes and mins can occur. So let's get into the extreme value theorem, and I'm going to do one example, and then we'll be done. So it starts, if f is continuous on a closed interval AB, then f will have an absolute max and an absolute min. Okay, so that's part of it. Continuous on a closed interval guarantees an absolute max and an absolute min. But what's even more important is the absolute max or absolute min can only occur, these absolute extrema can only occur at two different places. And if you take a look at our graph, we'll see that. So let's just scroll back up. Absolute extrema could only occur at either critical points, like here, or at endpoints, right here. So when you're asked to find the absolute max or the absolute min of a function, okay, first off, if they phrase it like that, what's the absolute maximum value? They're looking for the y value, okay? And I'll show you how the questions, the way they're worded, can either be asking for the y value or the x value, okay? But the only places we have to check are critical points and endpoints. Okay, let me show you an example. Okay. So here's our problem. We have f of x equals x squared plus 8x minus 5. It says on the interval -6 to 5, find the absolute max and absolute minimum values of f. Okay, so what we have to understand here is that absolute max and absolute min values can only occur at critical points and endpoints. Whenever you're asked to find absolute maximum values or absolute minimum values, or both, what we want to do is go ahead and make a table of values. Okay? There are infinitely numbers between -6 and 5. Okay? We don't need to test all of them. We only need to test endpoints and critical points because of the extreme value theorem. So the endpoints should be very obvious because they give you the interval -6 to 5. And I like to list these from smallest to largest. So I know I'm going to have to test -6, and I know I'm going to have to test +5. But I also have to test any critical points. So to find a critical point, I take the derivative and set it equal to 0. But I also need to check -4. Now, the reason I write my endpoints on that first is because I will not test a critical point. Right? Let's say I got -10 for my critical point. Well, that's not on the interval -6 to 5. So I don't have to test it. Okay? But because -4 is in between -6 and 5, I do have to test it. So now what I have to do is plug each of these numbers. And notice I'm plugging them into f, because absolute min and absolute max are about making the highest f value. So I'm going to start by doing f of -6. Right? And usually we have to do this by hand. It's a little tedious, but it's something we have to do. We must test all three. So I'm going to find f of -6, as well as f of -4, as well as f of 5. I have to find all of those. And if I had more critical points that were on that interval, I'd have to test them too. I must test every critical point on the interval and every endpoint. Okay, so let's start with f of -6. All right. So, -6 squared plus 8 times -6 minus 5. -6 squared is 36 minus 48 minus 5. 36 minus 48 is -12 minus 5 equals -17. And I'm going to write that in my table right here. Okay, next I'm going to test f of -4. So I'm going to have -4 squared plus 8 times -4 minus 5. -4 squared is 16 minus 32 minus 5. 16 minus 32 is -16 minus 5 is -21. And lastly, I'm going to check f of 5. So I'm going to have 5 squared plus 8 times 5 minus 5. That's 25 plus 40 minus 5. 25 plus 40 is 65. 65 minus 5 is 60. That was the easy part. Now I just have to identify the absolute min and the absolute max based on what's the biggest f of x number, what's the smallest. So let's start with the absolute maximum value. Now here's where I need to be careful about the wording. Okay? The question is, for absolute max, do I report the number 5 or report the number 60? Well, if they say find the absolute maximum value of f, then I report 60 is the maximum value of f. Okay? But if they say at what x value does the absolute maximum of f occur, then I would report 5. Sometimes to cover your bases, you can say the absolute max of f is 60 and it occurs at x equals 5. That way, no matter what the question was, you'd get it right. Okay? I'm just going to answer this question by saying the absolute max value okay, so f has an absolute max of 60 on -6, 5. And then my absolute min would be -21 because that's the smallest number. And the extreme value theorem tells you that all we have to check are critical points and endpoints, because those are the only places where a maximum could apply as long as the function is continuous. All right, that's it for today. I'll see you guys on Monday. Talk to you later. 2 chains, bye.